Today we're going to be talking about overlapping similar triangles. So if a line parallel to one side of a triangle intersects the other two sides, then it divides those sides proportionally. There's that word proportionally again. In triangle RST, PQ is parallel to RS. PQ intersects RT and TS, and the segments RT and TS are proportional. This makes triangles RST and PQT similar. So when we have triangles that are similar like this, our strategy is going to be to draw them separated from one another. So here I have triangle PTQ. That's my small triangle. I'm going to draw a little sketch. Here it is in blue. PTQ. And triangle RTS. Now, of course, your angles won't exactly match up. Your angles won't exactly match up, but that's okay. Because all we're really looking for is to make sure that we can see what the side lengths are going to be, and you're going to see why in a second. Now, there is a corollary to this theorem. The corollary is that if three parallel lines intersect two transversals, then they divide the transversals proportionally. So I'm given that Rx is parallel to Sy, which is parallel to TZ. And since it divides those transversals proportionally, I could say that RS is proportional to ST, and that XY would be proportional to YZ. Or another way to set up something like this would be to take RS and set it over XY going across, and then ST and YZ. Either way that you would set this one up, notice that the cross products would still wind up being multiplied by one another, so it's okay. They would be equivalent proportions. So let's start with these, and we're going to look to determine the value of x in these diagrams. So to start with number 1, I'm going to highlight my small triangle and my big triangle like I did before. Here's my small triangle, and now I'm going to draw it over here. This side is 12, and this side is 8. In my larger triangle, the pink side, the entire length of the pink side is labeled as x, and on the right side, it's 24. So the nice thing about this, about the overlapping triangles, is that the corresponding parts are already in a really good position. 12 corresponds with x, and 8 corresponds with 24. So I can set up a proportion comparing them. So I'm going to keep triangle 1 on the top in my proportion, and we're going to put triangle 2 on the bottom to keep it consistent. So on the top, one of my sides is 12. In my other triangle, the corresponding side is x. In the small triangle, the other side is 8, and its corresponding side is 24. Now I'm going to cross multiply. 8x is equal to 12 times 24. 8x is equal to 288. I can divide both sides by 8 and get x is equal to 36. In this next question, I'm going to do the same thing. I'm going to highlight the small triangle and the large triangle. So in my small triangle, I'm going to put it up here, save some space. We're going to need a lot of space for this one. And my large triangle. Okay, so in my small triangle, one side is x plus 2. The other side is x minus 1. In my big triangle, they're not both, or the whole thing is not labeled yet. Only a piece of it is. This piece is x. This piece is x plus 2. I can add them together. If I add x plus 2, I get 2x plus 2. In my other side, same thing. I need to label the whole side. So I have x minus 1, and I need to add x minus 2. If I combine like terms, I get 2x minus 3. Again, my corresponding sides are already nicely shown for me. So I'm going to set up a ratio, a proportion, to compare them. So I'm going to keep triangle 1 on the top. In this case, that's my small triangle, the blue one, and triangle 2 on the bottom. So triangle 1, I'm going to put x minus 1. Its corresponding side in the other triangle is 2x minus 3. The other side is x plus 2. Its corresponding side is 2x plus 2. So now I'm going to cross multiply. Now with this question, when I cross multiply, I wind up having a binomial times a binomial. And when we have a binomial times a binomial, we can either do double distribution or we can use box method. But either way, we're going to have a large binomial, a large trinomial probably at the end. So let's figure this out. X times 2x is 2x squared. X times 2 is plus 2x. Then I'm going to go to my second term. Negative 1 times 2x is negative 2x. Negative 1 times 2 is negative 2. And that's equal to 2x times x is 2x squared. 2x times 2 is 4x. Negative 3 times x is minus 3x. And negative 3 times 2 is minus 6. Now we do have some like terms in here that we can either add together, or in the case on the left-hand side, they wind up canceling out. But I get 2x squared minus 2 on one side and 2x squared plus x minus 6 on the other. Now, in order to solve this, I'm going to need to get all of my x squareds on one side. So when I do that, they wind up canceling out, which is super nice. And it won't always work out that way. Negative 2 is equal to x minus 6. So to solve for x, I can add 6 to both sides and get x is equal to 4. We're going to try another one. This one's not going to be as nice. So again, we're going to start with our small triangle and our big triangle. And I'm going to draw them separated from one another. Here's my small triangle. I have a 5 and I have x plus 1. And my big triangle, I have x plus 3, and I need this whole length. So that would be x plus 1 plus 8, which would be equal to x plus 9. Now I can set up my proportion. 5 corresponds with x plus 3. X plus 1 corresponds with x plus 9. If I cross multiply, I have 5 times x plus 9 equal to x plus 3 times x plus 1. On the left-hand side, I need to distribute, so I'm going to get 5x plus 45. On the left-hand side, I need to double distribute or use box method. But either way, I get x squared plus 3x plus 1x plus 3. And I can combine terms on the like terms on the right-hand side to get plus 4x plus 3. Notice that all my x squareds are already on one side of my equal sign. If I have x squareds on one side of my equal sign, that's a hint that I'm going to need to factor. So in order to factor, I need to move everything to one side of my equal sign because it needs to equal 0 before I can factor. Once I have a binomial or a trinomial like this, I can factor this. And to factor it, again, as a reminder, I'm going to think of factors of 42 that will add or subtract to -1. So because I know I'm looking for factors of 42, most commonly when you think of them, you're going to think of 6 and 7. So a 6 and a 7 are my two factors. Because it's multiplying to a -42, I know that one of these needs to be negative and the other needs to be positive. But because it adds to -1, that means that my bigger number needs to be negative. I'm going to squish over into the next box a little bit. So now I have x plus 6 times x minus 7 equals 0. Now when I have something like this, I'm going to separate that. That must mean that x plus 6 equals 0 or x minus 7 equals 0. I can get x is equal to -6. or x is equal to 7. So looking back at my question, I'm going to determine if it makes sense if I have a negative number. So looking at my question, I see that one of the sides of my triangle is x plus 1. If I have negative 6 plus 1, that does not make sense. So I'm going to cross out this negative 6, and I'm going to write the word reject. So my answer is x equal to 7. We're going to do one more question, and this one is actually more straightforward than the last one. So again, I'm going to take my small triangle and my big triangle. Also, guys, if you're having trouble with factoring, you can see some other videos that I have on this channel regarding how to factor, whether it is a binomial like that, where x squared is equal, the coefficient of x squared is 1, or if the coefficient of x squared is a different number, like 2. All right, so let's take a small triangle here. I have an x and a 5, and in my big triangle, together these give me 9, and then this is x plus 3. So to set up my proportion, I can compare 5 to 9 and x to x plus 3. 9x is equal to 5 times x plus 3. 9x is equal to 5x plus 15. Woo. Here we go. If I subtract 5x from both sides, I get 4x is equal to 15, or if I divide, x is actually equal, or x is not equal to a whole number, but that's okay. X is equal to 3.75. It is totally okay for x to be equal to a number that is not a whole number. Sometimes it's okay for x to be equal to a negative, but it all depends on the problem. The reason why that other question, it could not be a negative, is because in the question, I cannot have a negative side length. All right, guys, thank you so much for watching this video. I hope this helped you understand a little bit more with overlapping similar triangles, and I will see you soon.